Look up at the night sky and you see it, the moon. That big, glowing, faithful companion that has been hanging over our planet for billions of years. It controls our tides, it lights up our nights, and it's the only other world humans have ever stepped foot on. Since the dawn of time, we have looked up and assumed we were in a one-on-one relationship. One Earth, one moon. But what if I told you that our cosmic neighborhood is a lot more crowded than your high school science textbook led you to believe? Astronomers have recently confirmed that Earth has a second moon. It's not a ghost, it's not a glitch in the telescope, and it's not a secret satellite launched by a billionaire. It is a genuine rocky celestial body that has been orbiting our sun right alongside us for thousands of years, and we are only just now starting to understand its strange, looping journey through the void. This isn't just a tiny speck of dust or a piece of space junk. This is an object known as 2023 FW13, and its discovery is shaking up everything we thought we knew about Earth's gravitational grip on the solar system. Now, before you go out and buy a second telescope or start expecting double tides at the beach, there's a catch. This isn't exactly a moon in the traditional sense. Scientists call it a quasi-moon. But don't let the name fool you. Even if it doesn't circle us in a perfect circle like our main moon, it is inextricably tied to our planet's destiny. To understand how we missed a whole second moon for so long, and what it's actually doing up there, we have to look at the incredible physics of orbital mechanics and the high-tech surveys that are finally mapping out the dark corners of our sky. For a long time, we thought we had the Earth's orbit all figured out. We knew about the asteroids in the main belt between Mars and Jupiter, and we knew about the near-Earth objects that occasionally zoom past us. But the idea that something could be stuck to Earth without us noticing for centuries seemed impossible. That was until March of 2023. When the Pan-STARRS Survey Telescope in Hawaii caught a glimpse of something moving in a very peculiar way. At first, it looked like just another asteroid. But as the researchers at the Minor Planet Center began to plot its path, they realized this wasn't just passing through. It was sticking around. The orbit of 2023 FW13 is unlike anything you've ever seen. While our primary moon orbits Earth at a distance of about 240,000 miles, this new companion is much, much further away. It sits at the very edge of Earth's Hill sphere, which is the region of space where a planet's gravity is the dominant force. In fact, it travels so far away from us during its orbit that it actually ventures closer to Mars at times and closer to Venus at others. Yet it always comes back. It travels in a synchronized dance with Earth, taking exactly 1 year to circle the Sun, just like we do. Because its orbital period is so perfectly matched to ours, it appears from our perspective to be circling the Earth, even though it's technically orbiting the Sun. This is why it's called a quasi-moon. It's a cosmic squatter that has decided to follow us through the galaxy. How big is this thing? Well, it's not exactly a behemoth. Estimates suggest it's only about 10 to 15 meters across. That's roughly the size of a 5-story building or a large city bus. Because it's so small and so far away, it's incredibly faint. It doesn't reflect much sunlight, which explains why it stayed hidden for so long. Even our most powerful telescopes have to be pointed at exactly the right spot at the right time to catch a glimpse of this tiny traveler. But don't let its size diminish the importance of the discovery. Finding a companion like this tells us a huge amount about how Earth interacts with the debris field of the solar system. It suggests that there might be dozens or even hundreds of these mini-moons and quasi-moons floating around us, waiting to be found. What's even more mind-blowing is how long 2023 FW13 has been our neighbor. When astronomers back-calculated its orbit, they discovered that it didn't just arrive yesterday. This object has likely been in Earth's vicinity since at least the year 100 BC. Think about that for a second. While the Roman Empire was rising, while the Great Wall of China was being built, while the Industrial Revolution changed the world, this tiny rock was silently following us through the dark. And it's not planning on leaving anytime soon. Its orbit is stable enough that it will likely remain our quasi-moon until at least the year 3700. We've had a secret partner for over 2,000 years, and we're set to keep it for at least another 1,500. Now you might be wondering, if it's orbiting the Sun and not the Earth, why do we call it a moon at all? To answer that, we have to talk about something called a one-to-one resonance. This happens when two objects in space have orbital periods that are almost identical. Imagine two cars driving on a circular track. Even if they are in different lanes and moving at slightly different angles, if they complete a lap in the exact same amount of time, they will stay next to each other for the entire race. To an observer in the inner car, It looks like the outer car is orbiting them, moving forward and backward in a loop. That's exactly what's happening with 2023 FW13. It is looping around Earth in a giant stretched-out path that takes it millions of miles away. But because it's synced with our lap around the sun, it never truly leaves our side. This isn't the first time we've found a friend like this. Back in 2016, astronomers discovered 469219 Kamoalia, another quasi-moon that is much larger, about 50 meters across. Kamoaliwa is actually even more stable than our new friend, and some scientists think it might actually be a chunk of our primary moon that was knocked off during an ancient asteroid impact. But 2023 FW13 is different. Its orbit is much more elongated and eccentric. It's like the adventurous cousin that wanders off into the woods but always shows up back at the house for dinner. The fact that we are finding more of these objects now is a testament to how far our observation technology has come. We are no longer just looking at the big, bright things in the sky. We are starting to see the subtle, dark, and complex movements of the small stuff. But why should we care about a house-sized rock millions of miles away? Well, for one, these objects are the perfect targets for future space missions. Getting to Mars or the asteroid belt takes months or years of travel and immense amounts of fuel. But these quasi-moons are like floating gas stations or scientific labs right in our backyard. Because they are so close to Earth's orbit, the amount of energy required to reach them is relatively low. We could send small, low-cost probes to 2023 FW13 to study its composition. Is it a solid rock? Is it a pile of rubble held together by gravity? Does it contain water ice or precious metals? By studying these second moons, we can learn about the raw materials that formed our planet, and perhaps even find resources that could support human life in space. Imagine a future where we don't just have satellites orbiting Earth, but outposts on our quasi-moons. They could serve as relay stations for deep space communication or as parking lots for ships preparing to head to the outer solar system. Because they are already moving at roughly the same speed as Earth, they provide a much easier jumping-off point than a planet with deep gravity. 2023 FW13 might be small, but it represents a huge opportunity for exploration. The discovery also highlights a fascinating phenomenon in celestial mechanics known as the three-body problem. In physics, predicting how two objects will orbit each other is easy. But once you add a third object, like the Sun, the Earth, and an asteroid, the math becomes incredibly chaotic. These quasi-moons exist in a delicate sweet spot where the gravity of the Earth and the Sun are playing a tug-of-war. For a few thousand years, the Earth wins enough to keep the object close, but eventually, the gravitational perturbations from other planets like Jupiter will nudge the object out of its rhythm, and it will go back to being a regular asteroid orbiting the Sun. This means our second moon is a temporary visitor on a geological timescale, making our time with it even more special. What's truly exciting for the scientific community is the possibility that there are even smaller objects orbiting Earth that are truly captured. These are called mini-moons. Unlike quasi-moons, which orbit the Sun, mini-moons actually enter a proper orbit around Earth for a short period of time before being flung back out into space. We've seen this happen before. In 2006, a tiny object called 2006 RH120 circled Earth for about a year before leaving. Then in 2020, we found 2020 CD3, which had been orbiting us for several years without anyone noticing. These mini-moons are like cosmic hitchhikers. They hop on for a few laps around the block and then move on. 2023 FW13 is a bit different because it's a long-term companion, but it's part of the same mysterious family of objects that blur the line between asteroid and moon. When we talk about 2023 FW13, we are also looking at the history of our solar system. Most of the near-Earth asteroids come from the main asteroid belt, nudged out of their homes by Jupiter's gravity. By studying the orbits and compositions of these companions, we can trace their journeys across millions of miles. Was 2023 FW13 part of a larger planet sesamoll that shattered long ago? Or is it a pristine piece of the early solar system that has been floating in the void since the planets first formed? Every time we find a new object like this, it's like finding a new piece of a giant jigsaw puzzle. It helps us understand the violent, chaotic history that led to the stable world we live on today. But let's go back to the idea of no one knowing about it. How is it possible that in an age of high-speed internet, global satellite coverage, and thousands of professional and amateur astronomers, a 15-meter rock could just hang out near Earth for 2,000 years unnoticed? The answer is simple. Space is big. Really big. You might think you have a good handle on how much empty space there is between here and the moon, but the reality is staggering. You could fit every single planet in our solar system, from Mercury to Neptune, in the gap between the Earth and our primary moon, and you'd still have room to spare. Now imagine trying to find a rock the size of a bus in a volume of space that is millions of times larger than that. It's not just a needle in a haystack. It's a needle in a haystack the size of a mountain. To find these things, we have to use specialized telescopes like Pan-STARRS. These telescopes are designed to scan the entire sky every few nights, looking for anything that moves. Most of what they find is mundane, but every once in a while, they see a tiny dot that isn't where it's supposed to be. Computer algorithms then take that data and calculate the trajectory. It takes months of observation to confirm an orbit. You have to rule out that it's not a sensor glitch, or a distant comet, or a man-made object like a spent rocket stage. In fact, many new moons turn out to be old Apollo-era hardware that has finally come back around to visit us. But 2023 FW13 has been confirmed to be a natural solar system object. It's the real deal. This discovery also sparks a lot of conversation about Earth's planetary defense. If we can miss a second moon for 2,000 years, what else are we missing? Now don't worry, 2023 FW13 is no threat to us. Its orbit keeps it a safe distance away, and even if it did enter the atmosphere, its small size means it would mostly burn up before reaching the ground. But the technology we use to find these quasi-moons is the exact same technology we use to track potentially hazardous asteroids. Every time we discover a companion like this, we are essentially calibrating our planetary defense systems. We are proving that we can find small, dark objects in deep space. It's a practice run for the day we might find something that we actually need to worry about. There's also a deeply philosophical side to this discovery. For most of human history, the moon was a symbol of the unique and special nature of Earth. It was our one companion in the dark. But as we discover more quasi-moons and mini-moons, we realize that Earth isn't just an isolated marble. It is a gravity well that is constantly interacting with the environment around it. We are not just traveling through space, we are sweeping through it, picking up companions and discarding them over thousands of years. It makes the Earth feel less like a static object, and more like a living thing that is constantly engaging with the cosmos. What else might be out there? Some astronomers suggest that Earth might have a dust cloud moon. This is a region of space known as the Lagrange points, where the gravity of the Earth and the moon balance out perfectly. These points can trap clouds of dust and gas, creating what are essentially ghost moons. We've seen hints of these Kordylowski clouds for decades, but they are so faint that they are even harder to detect than a solid rock like 2023 FW13. If we can confirm the existence of these dust moons, it would mean that Earth's reach extends even further into the subtle mechanics of the solar system. When we think about these discoveries, it's easy to get lost in the numbers and the jargon. But at its heart, the story of 2023 FW13 is a story of exploration. It's about the fact that even in 2024, there are still major things about our own planet that we are just beginning to learn. We often feel like everything has been explored, that every corner of the map has been filled in. But discoveries like this remind us that the map is much bigger than we thought. The Earth system doesn't stop at the atmosphere or even at the orbit of the moon. It stretches out for millions of miles, filled with tiny travelers and secret companions. As we continue to develop better telescopes like the Vera C. Rubin Observatory, which is set to come online soon, we will likely find that 2023 FW13 is just the tip of the iceberg. We might find that Earth has a dozen quasi-moons at any given time, each on its own strange looping journey. We might find that some of these objects have been with us since the very beginning, trapped in stable pockets of gravity for billions of years. Each one would be a time capsule, holding secrets about how our corner of the universe came to be. The interest in 2023 FW13 isn't just limited to professional astronomers. The amateur astronomy community has been buzzing with excitement. Having a new moon, even if it's a quasi-moon, gives people a new way to visualize our place in space. It's a wonderful teaching tool. It helps explain that orbits aren't just perfect circles on a piece of paper. They are wobbling, shifting, complex paths influenced by everything around them. It helps people understand that gravity isn't just something that keeps our feet on the ground, but a giant, invisible web that connects us to every other object in the solar system. Think about the sheer persistence of this little rock. It has survived for billions of years in the harsh environment of space. It has dodged collisions, survived the intense radiation of the sun, and managed to find a stable rhythm with a planet millions of miles away. There is something almost heroic about its lonely journey. For 2,000 years, it has been our shadow, never asking for attention, just doing its yearly lap. Now that we finally know it's there, it feels like we owe it a bit of recognition. It's also interesting to think about the naming of these objects. While 2023 FW13 is its scientific designation, objects like this often get more poetic names once they are better understood. Kamo'aliwa, for instance, comes from a Hawaiian creation hum and refers to a celestial object that moves on its own. What will we call 2023 FW13? Perhaps something that reflects its long, secret history with humanity. The naming of celestial bodies is one of the ways we bring the cold, distant facts of science into our cultural story. It makes these distant rocks feel like a part of our world. One of the biggest questions scientists are currently tackling is whether these quasi-moons could be used as a planetary shield. While they are too small to stop a major asteroid on their own, understanding how they are captured and held in orbit could help us figure out how to capture and move other asteroids. If we can understand the sweet spots of Earth's gravity, we might be able to redirect a dangerous asteroid into a stable quasi-moon orbit, turning a threat into a harmless neighbor. It's science fiction for now, but the discovery of 2023 FW13 provides the real-world data we need to start making those calculations. The discovery also has implications for the search for life on other planets. When we look at exoplanets in other star systems, we are usually just looking for the planet itself. But if Earth has a halo of quasi-moons and mini-moons, it's likely that other habitable planets do too. These smaller companions could play a role in the stability of a planet's environment. They could influence the tides or provide a shield against incoming debris. By studying our own second moon, we are learning what to look for when we scan the stars for other worlds like our own. What if 2023 FW13 isn't actually a natural rock? Now, don't get too excited. Scientists are 99.9% sure it is. But the search for technosignatures, signs of alien technology, often involves looking for objects in unusual orbits. A quasi-moon orbit would be a perfect place for an alien probe to park itself if it wanted to observe Earth for a long period of time without being easily detected. While there is no evidence that our new neighbor is anything other than a normal asteroid, the fact that it's in such a perfect spot for observation makes it a high-priority target for those interested in the search for extraterrestrial intelligence. Just imagine the world's reaction if we sent a probe to this second moon and found something that wasn't made of rock. But even if it's just a rock, its value to science is immense. Every asteroid is a sample of the early solar system, frozen in time. Because 2023 FW13 is so close and accessible, it's like having a laboratory sample sitting on a shelf just out of reach. We can use spectroscopy to determine what minerals it's made of. We can look at how its surface has been weathered by the solar wind. This tells us about the environment of our solar system and the history of the sun's activity. For a geologist, this isn't just a rock, it's a history book. The way we found 2023 FW13 also demonstrates the power of big data in modern astronomy. The Pan-STARRS telescope produces terabytes of data every single night. No human could ever look through all of it. It takes sophisticated machine learning algorithms to sift through the billions of stars and galaxies to find the one tiny dot that is moving differently. This discovery is as much a triumph of computer science as it is of astronomy. It shows that as our tools for processing information get better, the universe actually starts to reveal more of itself to us. As we wrap our heads around this, one of the most exciting thoughts is that we are just at the beginning. If we found 2023 FW13 in 2023, what will we find in 2025 or 2030? We are entering an era where we will have a real-time, high-resolution map of everything in our cosmic neighborhood. The empty space around Earth is going to start looking a lot more populated. We will see the ebb and flow of mini-moons, the long-term dances of quasi-moons, and the sudden arrivals of interstellar visitors like Oumuamua. Our view of Earth is expanding from a single point in space to a complex, busy hub of activity. It's a great time to be interested in space. We are no longer limited to the blurry photos and grainy footage of the past. We have telescopes that can see across the universe and algorithms that can find a bus in the dark millions of miles away. The discovery of Earth's second moon is a reminder that the universe is full of surprises, and that even the things we think we know best, like our own planet, still have the power to amaze us. So the next time you look up at the moon, give a little nod to the other one. You won't be able to see it with your naked eye, but it's there. 2023 FW13. Our tiny, faithful, house-sized companion is looping around us right now, just as it has for the last 2,000 years. It's part of our story now, a testament to our growing ability to see the invisible and understand the complex. It's a small rock in a big universe, but it's ours. Think about the sheer scale of the time 2023 FW13 has spent with us. When it first arrived in its current orbit around 100 BC, humans were just starting to figure out the basic principles of engineering and math. We thought the Earth was the center of the universe. We thought the stars were lights on a giant dome. And all the while, this little rock was there, proving that the universe was much bigger and more complex than we could imagine. Now, 2 millennia later, we finally have the tech to say hello. It's a beautiful closing of a loop that has been running since before the Common Era. The stability of its orbit is also a point of intense study. How does it stay so consistent despite the gravitational pulling from the Moon, the Sun, and other planets? It turns out that 2023 FW13 is in what's called a librating orbit. It wobbles back and forth in a way that naturally corrects itself. It's like a ball rolling around the bottom of a bowl. If it gets pushed a little to one side, gravity naturally pulls it back to the center. This self-correcting nature is what allows it to stay our neighbor for thousands of years instead of just drifting away. As we look to the future of space travel, these quasi-moons provide a perfect stepping stone to the rest of the solar system. If we want to build a sustainable presence in space, we need to learn how to operate in these complex, low-gravity environments. Sending humans to a quasi-moon would be much safer and easier than sending them to a distant asteroid or another planet. It could be the training ground for the first generation of true space explorers. We could test our life support systems, our mining techniques, and our navigation skills, all while staying relatively close to home. The discovery also reinforces the idea that we are part of a larger Earth-Moon system that includes much more than just the 2 biggest bodies. This system is a dynamic, evolving structure. It's a reminder that we are not living on a solitary island, but in a vibrant ecosystem of celestial bodies. Every discovery of a new quasi-moon or mini-moon adds a new layer to our understanding of this ecosystem. In many ways, 2023 FW13 is a symbol of the new astronomy. Information that used to be the domain of a few elites is now being shared with the world in real time. We can follow the progress of the discovery, look at the orbital diagrams ourselves, and participate in the excitement. It's bringing the wonders of the universe down to Earth, making us all feel like part of the team exploring the final frontier. So, as we continue to track this mysterious second moon, let's appreciate what it represents. It's a bridge between our ancient past and our high-tech future. It's a tiny piece of the cosmic puzzle that has finally clicked into place. And most importantly, it's a reminder that there is always more to find, always more to learn, and always more to wonder about. The sky is not the limit, it's just the beginning. What's really fascinating about 2023 FW13 is that its discovery wasn't just a fluke. It's part of a concerted effort to find every single object that comes near our planet. This is a monumental task. There are estimated to be millions of asteroids in our solar system, and we've only mapped a fraction of them. Every time a telescope like Pan-STARRS or the upcoming Vera-C Rubin Observatory scans the sky, it's not just looking for moons, it's looking for the history of our cosmic neighborhood. Every rocky body we find tells us something about the conditions of the early solar system, from the temperature of the primordial dust cloud to the frequency of collisions that eventually led to the formation of the planets. Scientists are also intrigued by the color of 2023 FW13. By looking at how it reflects different wavelengths of light, they can get a rough idea of what it's made of. Is it an S-type asteroid rich in silicates and nickel iron? Or is it a C-type, full of carbon and perhaps even organic molecules? These details might seem small, but they are crucial. If 2023 FW13 is rich in certain minerals, it could be a goldmine for future space miners. We often talk about asteroid mining as a far-off concept, but having a target this close and this stable makes it feel a lot more like a reality. It's essentially a natural resource depot just sitting in a predictable orbit, waiting for us to figure out how to reach it. There's also the psychological impact of having more than one moon. Throughout human culture, the moon has been a singular, powerful archetype. It's the mother, the goddess, the constant. Now, we have to adjust that archetype to include these smaller, transient companions. While 2023 FW13 won't show up in our poetry or myths as vividly as the primary moon, Its presence changes the vibe of our planet. We are no longer a lonely traveler. We are part of a convoy. This shift in perspective, from being a solitary planet to being the center of a complex celestial dance, is one of the most profound outcomes of modern astronomy. Interestingly, the existence of quasi-moons like 2023 FW13 might also help us understand the lunar origin theory. If the moon was indeed formed from a massive collision between Earth and a Mars-sized object billions of years ago, there would have been a massive amount of debris left over. While most of that debris eventually formed the moon or fell back to Earth, some of it might have been ejected into orbits that stay close to the Earth-Sun system. Could 2023 FW13 be a leftover from that ancient violent event? If it turns out that 2023 FW13 has the same chemical signature as the Earth and the Moon, it would be a smoking gun for our planet's origin story. This makes the tiny rock much more than just a neighbor. It makes it a relative. As we look at the orbital mechanics again, the sheer luck of 2023 FW13's path is astounding. To be in a one-to-one resonance with Earth, an object has to be moving at a very specific speed at a very specific distance. If it were just a tiny bit faster or slower, it would eventually drift away and become a normal asteroid. The fact that it has stayed in this sweet spot for over 2,000 years suggests that its entry into this orbit was a very precise event. Some astronomers spend their entire careers studying these resonances because they are the keys to understanding how solar systems remain stable or fall into chaos over billions of years. Moreover, the discovery of 2023 FW13 is a testament to international cooperation. The data comes from Hawaii, is processed by researchers in the United States, checked by the Minor Planet Center, and analyzed by astronomers all over the world. Space is the one area where humanity truly seems to work as a single species. We aren't looking for American moons or Chinese moons. We are looking for Earth's companions. This shared wonder and shared goal is one of the most positive aspects of scientific discovery. In the grand scheme of things, 2023 FW13 is a tiny dot in a vast ocean, but for us, on this small blue marble, it's a big deal. It's a reminder that we are still in the early stages of understanding our own home. We've mapped the surface of our planet, we've explored the depths of our oceans, and now we are finally starting to map the suburban space around our world. Every new object, every new orbit, and every new second moon brings us closer to a complete picture of our place in the universe. It's a journey that began with the first humans looking up at the stars, and it's a journey that continues with every new piece of data we pull from the sky. So let's keep watching the stars, keep supporting the telescopes, and keep asking the big questions. The universe is a lot busier than it looks, and there are plenty more secret neighbors just waiting to be found. Whether they are big rocks, tiny dust clouds, or ancient relics of the solar system's birth, each one has a story to tell. And for the first time in history, we are finally ready to listen. 2023 FW13 is just the beginning of a whole new chapter in our relationship with the cosmos. Here's to our secret companion, and to many more discoveries to come. Our cosmic family is growing, and the view has never been better.